Plastic is efficient. However, its durability backfires as a problem in biodegradation. Other problems such as food scarcity and greenhouse gas emissions from meat production are also serious. Mealworms are a matching solution to both problems. Recognized for their potential as a healthy food source, mealworms possess the amazing ability to decompose plastic and food waste in an eco-friendly way. However, the worms, when densely packed together, are in danger of mass mortality events due to the packaging's inability to release toxic gases and maintain enough oxygen. The lack of space between each worm also poses the problem of cannibalism. Currently existing alternatives, such as subdividing worms into separate containers, are time-consuming and inefficient. In order to solve such problems, we introduced Mealtopia, a breakthrough eco-habitat for mealworms.
Mealtopia is an innovation that provides a cost-effective structure that maximizes mealworm survival and efficiency. The key factors of MMEs are identified as the lack of oxygen and high rates of toxin, CO2, and humidity resulting from poor ventilation. We hypothesized that the increased surface area of the mealworm population would benefit their modulation of oxygen, temperature, and humidity, resulting in decreased MMEs. By combining biological and engineering solutions, we plan to reduce mealworms' contact and therefore promote enough ventilation. This could be achieved through designing a 3D model that could ensure adequate physical gaps between the mealworms in a simple yet effective way.
We figured that making a 3D structure that could be put to use just by simply adding it to the mealworm community would be a passive, energy-saving, and cost-effective solution. Termite mound, known for its careful constructions of tunnels for airflow, inspired our design. During the design process, we ensured the structure's tortuousness and ability to accommodate mealworms of varying sizes. By using programs like SolidWorks and Tinkercad, we completed our final design and used a 3D printer to make it ready for testing. The structure's material, polylactic acid, also known as PLA, possesses additional sustainable advantages due to its 100% renewability and carbon neutrality. Also, we expected ventilation effects through its micropores.
To put this structure to a test, we prepared several equipment such as vernier oxygen sensor and biochamber. The test aimed to prove the structure's efficiency by observing oxygen consumption when there were only mealworms present in the biochamber and when the 3D structure was added inside as well. We placed 1,000 mealworms weighing 339 grams in a hermetic air block biochamber. Then we observed the internal oxygen concentration level, which was constantly decreasing due to the respiration of the mealworm population. We applied linear fitting to the time course of oxygen level and obtained the slope as oxygen consumption rate reveals how many mealworms survive at the given time frame. In our experiments, the oxygen consumption rate of 1,000 mealworm population decreased along 48 hours. In the control test without any structure, we observed 61% decrease in respiration rate, which also implies a mortality rate. On the other hand, under the presence of the 3D structure, we observe 55% decrease, and it implies that Mealtopia's structure can possibly reduce mealworms' mortality by 6%. Additional experiments and statistical testing are required to prove our statement.
Market research reveals a paradigm shift towards sustainable protein sources, with the mealworm market witnessing exponential growth. According to SkyQuest, the global mealworm market is set to soar from $0.16 billion in 2022 to a staggering $1.27 billion by 2030. We aim to revolutionize the mealworm industry, focusing on sustainability. Advanced transportation methods become a marketing strategy, educating consumers on the benefits for both the environment and the product quality. Innovators in mealworm transportation position themselves as leaders, differentiating through commitment to cutting-edge sustainable practices. We target businesses, public agencies, restaurants, and schools as mealworm usage expands. Startups and individual farmers eager to enhance efficiency become our early adopters.
We are excited to combine our diverse skills, aiming to address upcoming challenges creatively and effectively.